Today we'll be doing a quick review of Introduction to Matter. Go ahead and open up your blue Physical Science review packet. Turn to page 3. Let's first start by investigating the terms element, compound, and mixture. Look at the definitions on the left-handed side of the screen. Look at the images on the right-handed side of the screen. Can you appropriately match the definitions to the images? Let's first investigate elements. Remember, an element is a substance that cannot be broken down into any other substances by physical or chemical means. Look at the images on the right. We have a bowl of soup, a lump of coal, and a diamond, and we have water. Which of these images would be showing you an element? If you answered that the lump of coal or diamonds are showing you an element, you would be correct. You learned this year that coal is actually made out of carbon, and that coal that's undergone heat and pressure for millions of years will turn into diamonds. This would be an example of an element. Now try to identify an example of a compound. If you looked at this image down here and you saw one oxygen chemically combined with 2 hydrogen atoms in a specific ratio, you would have appropriately identified water as a compound. Remember that a compound is a substance made out of 2 or more elements chemically combined in a specific ratio, which would then leave our bowl of soup to be a mixture. Our bowl of soup is a mixture because you have 2 or more substances that have come together. They're in the same place, they're all in the bowl. However, they are not chemically bonded, which means if you don't like carrots in your bowl of soup, you can easily pick them out, right? Because they are not combined or bonded with things like the potatoes or the peas or even the meat. This is an example of a heterogeneous mixture. Remember, heterogeneous mixtures are where you can see the different parts of the mixture. A homogeneous mixture would be something like the broth. There's multiple things that come together to form the broth and soup, and they are not chemically combined. However, you cannot see the different parts. In your note-taking packet, do not forget to give examples of elements, compounds, and mixtures. Now, let's look at physical properties. What are physical properties? Physical properties help us identify matter. Look at this apple. How would you describe it? If you said red, smooth, round, green leaf, brown stem, juicy interior, those would all be physical properties of an apple. Physical properties are really just how we observe or measure matter without actually changing the matter's identity. Now, there's a couple things that fall under physical properties. Let's use aluminum from this point out to describe physical properties. Let's look at this aluminum pan. How would you infer ways in which this aluminum pan is used? If you said to bake a cake or make lasagna, those would be correct. And what does that mean about aluminum? If you said that aluminum is thermally conductive, you would be correct. Remember that thermal conductivity is how well a substance transfers heat. Can you think of examples of things that transfer heat well, or examples of things that do not? Heat is not the only thing that can be conductive. Also remember we have electricity. Electrical conductivity is another part of a physical property. If you look here, you can see that there is glass in between these 2 wires. Notice that the light bulb is not illuminated, meaning that glass is not thermally conductive. Let's try wood. If we were to put wood between the 2 wires, you would see that also the light bulb does not light up. Why? Because wood would be considered an insulator. Now let's try slate or graphite. Notice when the graphite gets put between the 2 wires, you can see that the light bulb illuminates. Why? Because graphite is electrically conductive. Let's look at another way that we can physically describe matter. Let's go back to our aluminum. Let's look at this aluminum foil. The fact that aluminum foil can be pounded into thin sheets is known as malleability. Malleability is another physical property of matter. The third physical property of matter is the idea that something can sink or it can float when placed in water. And remember, we learned about this earlier. Another physical property of matter is density. Density is how much mass is in a given space. So the density of aluminum is 2.7 grams per milliliter, which means if you were to place density into a beaker, it would sink because aluminum is more dense than water. Let's look at calculating density. Do you remember this guy, the heart? Do you remember how much you love density? Remember, the definition for density is really mass over volume. And you can see that if you heart density and you shoot an arrow through it, you have m over v. Remember, the units for mass are grams and the units for volume are cubic centimeters. So the units for density would then be grams per cubic centimeter. Let's shift gears slightly. Look at this image now of aluminum. Based on how this aluminum looks, what can you infer about aluminum based on this image? If you said it can be pulled into thin wires, you would be correct. And this is called ductility. This is the fifth physical property of matter. Another physical property of matter is states of matter, meaning can it be a solid, a liquid, or a gas? Here on Earth, aluminum is found in both the solid and liquid state. State of matter is another physical property of matter. Now, don't forget, each element has its own unique freezing, melting, and boiling point, which means it has its own unique temperature in which it will solidify into a solid, it will evaporate into a gas, or it'll melt into a liquid. Let's look at the last physical property of matter, and that is solubility. Look at these two images here. Can you figure out what solubility is based off of these two images? The idea that we can pan for gold in water, but we can't pan for salt. This is demonstrating the term solubility because solubility is how well does something dissolve in water, or H2O. Do not forget to write examples for all 6 physical properties in your note-taking packet. Make sure you have an example for thermal conductivity, malleability, density, states of matter, ductility, and solubility. Now that we've talked about how we can describe matter, now let's look at chemical properties. Chemical properties are now looking at how can we change matter. There's really only 2 ways you can change matter into a totally new substance. The first one is flammability. Flammability is looking at how easily will something catch fire. The second way we can change matter is reactivity. And reactivity is looking at how readily will something react with something else. For many elements on our periodic table, we've actually put them in a spectrum. Elements that are considered to be the most reactive to elements that are considered to be the least reactive. Remember, reactivity is the readiliness of it to react with something else. And if it does, well then something totally new forms. And this is known as changes. Let's first talk about physical changes. Physical changes is changing the size or the state of matter, but not actually changing it into a whole new substance. So physical changes, well, it matches its term. It physically looks different, but its identity is still the same. This is a key thing here. Physical changes could be things like ice melting or sanding wood or crushing a can, but at the end of the day, the ice is still H2O, and the sanded down wood is still wood, and the crushed can is still aluminum. It hasn't turned into anything new or different. Make sure you write down examples in your note-taking packet of physical changes. Now let's look at chemical changes. This is different. Because with chemical changes, the substance is literally changing chemically inside, meaning that the elements are realigning and forming a whole new substance. Remember that in all chemical changes, a new substance is formed. What are the signs that you have a chemical change? Do you remember these? You could have a gas produced. You could have a change in temperature, so the object feels warmer. You could have a solid formed or a precipitate. You could have a permanent change in color, something that cannot be undone. You can have an odor change. The substance could disappear, or light could be given off. Examples of chemical changes could be burning something, oxidizing it, like rust, digesting your food, or something reacting with acid. With all of these things, you cannot undo them. With a chemical change, once the change has occurred, it is not easily undone. But let's remember one thing. Whether we have a physical change or a chemical change, we are always adhering to the law of conservation of mass. You'll notice on the back side of your sheet, you will see on the top of the page the law of conservation of mass. The law of conservation of mass is defined for you here. The law of conservation of mass states that mass cannot be created or destroyed in any physical or chemical change. So if you look at this experiment here, you can see that we have sulfur and we have iron. This is on the reactant side of our equation. After the chemical reaction has occurred, which you can see here with the arrow, heat is given off and we now have iron sulfate. But please notice that the mass has been conserved. So we had 32 grams of sulfur before the experiment and we had 56 grams of iron. These are on the reactant side. After the chemical change has taken place and we now have iron sulfate, we still have 88 grams of our product. So no mass was created or destroyed in this chemical reaction. Please take a moment and answer questions 1 and 2 on the bottom of the very first page. The very first question asks, which of the following is not the result of a chemical change? Circle the answer to be correct, A, B, C, or D. Also, answer question 2. What is the best way to tell if a chemical change has taken place? Circle A, B, C, or D to be correct. Tomorrow, we will be investigating examples of physical and chemical changes during station activities.